Okay, so today I'm going to start going over sections 9.1 and 9.2 from the book, going over graphing quadratics. I do not like the videos on YouTube, so I'm going to make a series of videos. I think I definitely go over some shortcuts here that are not in any of the YouTube videos. So first thing we want to recognize when we're graphing quadratics is a quadratic function is a type of nonlinear function. Okay, so that means the rate of change is not constant. We know when the rate of change is constant, we refer to that as a slope, and those types of functions produce lines. Okay, if we have a constant rate of change, that would be a slope, and you would get a line. So since this is a nonlinear function, the graph of a quadratic function is not going to be a line. It's going to be called a parabola, which I'm going to cover in a minute. So here's our general form that we're going to start with today, our standard form. We will get into vertex form after we get back from spring break, but this is standard form. So y equals ax squared plus bx plus c, something that we've been dealing with plenty with our graphing and quadratic formula. A cannot equal 0 because if a is 0, then 0 times x squared is 0, and you no longer have a quadratic. Okay, so let's take a look at the simplest functions. We talked about these earlier in the year. The simplest function for any type of function would be called a parent function. So here's y equals x squared and y equals negative x squared. Now typically I would have you fill in the y values from these graphs in class, but as you can see, they're already completed. So what I'm going to take a look at here is x values from -2 to +2. If you plug those values in, you'll see you'll get these y values. So then I came down here and plotted the points. So you can see that we get our curve is actually a U-shaped curve instead of a line. Okay. And we can see here in negative x squared, it's also U-shaped, but this one's down. We would say this first one opens up and the second one opens down.